Section 3.5 is sort of long, so I'm actually going to break this up into two videos. The first part is implicit differentiation. So quite often we work with functions that are explicit functions of x. For example, this one, it says y equals, and then here is the function of x. So if you give me a value for x equals 1, I can just plug it in, put that in a calculator, and then I can tell you what y equals. An implicit, which is saying that it's implying that it's a function of x, would be something like this. Over here, I cannot solve for y. But if you give me a value for x, like a 1, then eventually with some work, I could find out what y equals. It's not as straightforward as this one, but it can be done. So when we go to take the derivative of something like this, on the left side, you would just say y prime equals, the derivative here is 2x, the derivative of sine is cosine. With this one, we would need to take the derivative on both sides of the equation. You take the derivative of the e function, that would be the e function, and then you'd have to take the derivative of the x and the y. So let's start off with something a little simpler than that one right there. Example number 1, here we go. So what if it's y equals, and then we've got something like 9x plus 1 to the 20th. All right, that's an explicit function of x. Go ahead and take the derivative, so it's going to be y prime equals, and then you do the power rule, have the 20 come in front and multiply. Leave the inside part alone, subtract 1 from the exponent, and then do the chain rule. So the derivative of the inside would be a 9, so multiply by 9. And of course you could put the 9 and the 20 together to make 180. But I'm building up to a point, so I'm going to move on to example number 2. Suppose that the function was raised to the 20th, and then inside the parentheses, there's a function known as happy face. So what's the derivative of that? So on the left side, you'd say y prime equals. You'd go through the same procedure, bring the 20 down and multiply. The happy face can just sit there while I'm taking the derivative of this outside function. And now I need to do the chain rule, take the derivative of happy face. But I don't really know what the derivative of happy face is, so what I have to do is say, here's happy face, and there's the derivative of happy face. So if it turns out that a happy face was the sine function, then right there I would say the derivative of sine is cosine. If the happy face was an e to the x, then the derivative of e to the x would be e to the x. But whatever that function is, its derivative goes on the outside. So for example number 3. So how about if it's x times y plus x squared plus y squared equals a 7. Now this is an implicit function of x. To be a little more clear, find the derivative dy dx. Or in other words, y prime for short. But with this notation here, it's got more information in it than y prime. Y prime is the shortcut. For example, my name is actually Gregory. That would be the full name, Gregory Scott Perkins. But pretty much everybody calls me Greg. So this is like saying Greg. This is the shorthand. This would be saying Gregory Scott Perkins. There's more information in this because this is saying that the y is the dependent variable and x is the independent variable. Okay, now on to the derivative. So for this one, I need to use the product rule. So the derivative of x would be 1, and then you leave the y alone. Plus, now leave the x alone and take the derivative of y. Well, that is just like this. Because I don't know what y equals, I can't actually put its derivative right there. So what I do is I say whatever y is, put its derivative right here. Then onto this x squared. The derivative of x squared will be 2x. What about the y squared? Well, you do the same thing with the power rule, but then, just like with this happy face, you also have to take the derivative of what's inside the square function. And what's inside is y, so then you need to multiply by y prime. And on the right side, the derivative of 7 is 0. Now, one little detail is right here, you might say, well, hey, you put 2y and then y prime. Why didn't you put 2x and then x prime? Good question. Well, since we're taking the derivative with respect to x, I can do that right here. I can say take the derivative of the squared function, so that puts the 2 in front, and then it's x to the 1, and then multiply by the derivative of x. Well, over here on the side, that's where this notation comes in handy. So take the derivative with respect to x. And if I take the derivative of x with respect to x, then that's dx over dx, which equals 1. So on this one, I could do the same thing and say put x prime right here, but x prime really means dx over dx. So then I would be multiplying by a 1, and it doesn't change it. Now I just have a couple steps to solve for y prime. So notice that y prime shows up right here and right here. So those terms that have y prime, leave them on the left side. The terms that don't have y prime, subtract them and move them to the right side. So the right side would look like I need to subtract y and also subtract 2x. And then for these two terms that have y prime, go ahead and factor it out. So factor out y prime, and then it would leave x plus 2y. And then there's only one last step, and that is divide both sides by this x plus 2y. So y prime equals negative y, negative 2x, and it's divided by x plus 2y. And then that can't be simplified, so that's y prime, that's the derivative. So for example number 4, how about that e to the xy plus the square root of y, and then equals x squared over y, that one that I started with at the beginning. Now let's take the derivative. So on the left side, the derivative of the e function is the e function. And then we need to do the chain rule, so take the derivative of x times y. For that, we need to use the product rule. So the derivative of x is 1, and then leave y alone, plus leave x alone, and take the derivative of y. Let me emphasize this little prime here. And then for the derivative of this square root function. So remember that the shortcut for the derivative of the square root function is 1 over 2 times that square root function. So I'm going to use that shortcut that I have memorized. So for this being the square root of y, its derivative would be 1 over 2 times the square root of y. And then we need to do the chain rule. Take the derivative of what's inside, and the derivative of y will be y prime. And then for the right side, for this one we need to use the quotient rule. The quotient rule, part of it says the bottom needs to be squared. And then take the derivative starting on the top. The derivative of the top would be 2x, and then leave the y alone, minus, leave the x squared alone, and take the derivative of the y. All right, now I've created quite a mess. No, it's not bad. So in this one, we need to solve for y prime, and y prime is showing up in 3 places. Now on top of that, I have some of these have denominators and some don't. So the first thing that I'm going to do is I'm going to clear out these denominators. I'm going to multiply by the least common denominator, which would be 2 square root of y times y squared. So multiply both sides by that. 2 square root of y and y squared. 2 square root of y and y squared. So when I multiply it here, it's just going to get multiplied with the e to the x. And then go ahead and distribute it. So we've got all of this that's going to be distributed to this y right here. So that means this is going to become y cubed. So there is 2 square root of y, y cubed, e to the xy. And then take this and distribute it over here. So then it would be plus 2x square root of y and y squared. And then also the e part. E to the xy. And then there would also be the y prime. Now when you multiply this over here, of course the 2 and the square root of y will cancel. So we just need to distribute the y squared over to here. So plus y squared times y prime. And then on this side, the y squareds are going to cancel. So I just need to distribute 2 and square root of y. And then distribute it to here, so there's going to be minus x squared, and then 2 square root of y, y squared, times y prime. Excellent. Now, everything that has y prime needs to be on one side. So there's already 2 terms that have y prime on the left side, so I'm going to take this one and move it to the left side. Since this doesn't have a y prime, I'm going to move it to the right side. So the left side is going to have this 2x square root of y, y squared, e to the xy, and a y prime, plus y squared, y prime. And now this term is negative, so when you move it to the left side, it'll become positive. And x squared, I guess I could put the 2 in front. Square root of y, y squared, and y prime. You know, when I wrote this one down, that's y squared. This is supposed to be y prime from that right there. Sorry about that. And then the terms that don't have y prime, they are on the right side. So 2, I guess I should have combined the 2 and the 2. Well, I'll do that in the next step. And then this, subtract it and put it on the other side. All right. Then if you factor out the y prime from all of these, it would be everything else that's left. So it's going to be y prime times the 2x squared of y, y squared, and the e function plus the middle one will just be y squared, and then 2x squared square root of y, y squared. I forgot to put the 2's together. Oh well, I'll do it in the next step. All right, now we're down to the last step. The last step is divide both sides by this whole string of letters right here. So finally, y prime equals And for this one, I'm finally going to put those 2's to get together. So that's 4xy in the square root of y minus 2 square root of y, y cubed, and the e function. And then divide both sides by this. So 2x squared of y, y squared, e to the xy, plus a y squared, plus a 2x squared square root of y, and y squared. That was fun. Now let's try one that isn't quite as long. So for example number 5. So what if we have tangent of y plus secant of x equals sine x times cosine y. Okay, the derivative of tangent is secant squared, so this will be secant squared y, and then I need to do the chain rule, take the derivative of y, that's y prime. The derivative for secant of x will be secant of x, tangent of x, and if you did the chain rule on this one, the derivative of x is a 1, so multiply by a 1, which of course doesn't change it, so you don't really have to write that 1. On the right side, I get to do the product rule. The derivative of sine is cosine of x, and then the cosine of y stays there. And then it would be plus, leave the sine of x alone, and then the derivative of cosine is negative sine of y times y prime. And then it's time for me to use the red pen to say this has a y prime in it, and this has a y prime in it. So those two should be on the same side. Since this one's negative, I'm going to move it to this side so that it becomes positive. So on the left side, we'd have secant squared of y times y prime. And then moving this term is going to make it positive. Sine x, sine y, y prime. And then those things that don't have a y prime, have them collected on the right side. So there would be the cosine x, cosine y, and then subtract secant x, tangent x. And then what I like to do is combine the last two steps, because I can see that I need to factor out y prime, and then what would be left is these two terms, and then I need to divide by them. So I'm going to do that as one step. So this side stays the same, the cosine x, cosine y. Look, it says cozy right there, isn't that cozy? Then secant x, tangent x. And then divide by this. After the y prime has been factored out, what's left is secant squared y plus the sine x and sine y. All right. Now, one more example. Like I said, this section, I'm cutting it in half because it is rather long. So this is implicit differentiation. And then part 2 will be using implicit differentiation for the derivatives of inverse trig functions. Woo, something to look forward to in the next video. But our last example is, suppose you have x to the 2/3 plus y to the 2/3 equals 1. Then find the derivative. More specifically, if x is equal to 1/2. So on this one, I'm going to need to do both calculus and algebra. Which shall I do first? Okay, calculus, sounds good. All right, so take the derivative. For this part, it's going to be 2/3 x to the what? So I need to subtract 1. 2/3 minus 1 is negative 1/3. And then here, the derivative is going to be 2/3 y to the negative 1/3. That part is pretty much exactly the same. But then you need to take the derivative of y, so that's going to be y prime. And then for the easy part, on the right side, the derivative equals 0. Now do the algebra to solve for y prime. Well, I don't like doing algebra with negative exponents, so I'm going to rewrite this as 2 over 3x to the 1/3 and 2 over 3y to the 1/3 times y prime equals 0. Okay, that looks better. Now subtract this term. So on the right side, it'll be negative 2 over 3x to the 1/3. And I'm going to multiply by the reciprocal of this. So I'm going to multiply both sides by a 3 on top and a y to the 1/3 on top and a 2 on the bottom. And then here as well, and of course, these are going to cancel. So y prime equals, and in fact, these 2's will cancel and these 3's will cancel. So what's left is y to the 1/3 over x to the 1/3. Now we're almost done. So you could see we're supposed to plug in x equals 1/2, but we also need the value for y. So that means we need to do algebra. So over here, I need to go back to the original equation and plug in 1/2. So 1/2 to the 2/3 power plus y to the 2/3 power equals 1. And then to solve for y to the 2/3 equals 1 minus 1/2 to the 2/3. And then to solve for y, raise both sides to the 3/2 power. So using the reciprocal, when you use the reciprocal on both sides to the 3/2 power and to the 3/2 power, then when you multiply these two exponents, they cancel each other out and you just have the y. Then I'm going to need to type this into a calculator. Luckily, I happen to have a calculator right here. The calculator seems to have fallen asleep. Okay, there we go. So I need parentheses, and then I need 1 minus, and I need parentheses. There's the 1/2. Raise that to the 2/3. Then move over, put parentheses, and raise all of that to the 3/2. So it's going to be that y equals a 0.225. All right, now we're down to the end. Y prime is equal to, take a 0.225 for the y value, raise that to the 1/3. 1/2 for the x value, raise that to the 1/3. So we've got negative 0.225 is raised to the 1/3. Oops, I didn't mean to hit enter. And then divide that by a 1/2, which is raised to the 1/3. And there we have the final answer. The derivative equals negative 0.766.